Welcome to O'Reilly Maths. This is the 2019 Leaving Cert Higher Level Paper 2, and we're looking at question number 2. Part A says that the line P makes an intercept on the x-axis at A0 and on the y-axis at 0B. This is our line P, where A and B are not equal to 0. Show that the equation of P, the equation of this line P, can be written as x over A plus y over B is equal to 1. Okay, so we're looking at the equation of P, which is a line. So the formulas for the equation of a line in our tables book, you have two choices. The one I'm going to choose is y is equal to mx plus c. And the reason I'm choosing this is because all you need for this is the slope and c the y-intercept. So m is the slope and then c is the y-intercept. And we can see in the diagram we can work out both of those things. Okay. So the slope, remember the slope is rise over run. In this diagram we can see here, if we take this triangle that's already formed, this would be our rise, and then this length here would be our run. So the slope is the rise over the run, so m slope is the rise over the run, which is, well, the rise here, this distance here is b, whatever the y-coordinate of this point is. So the rise is b, and the run then is a. It goes as far as this point here, a comma 0. So the run is a. Now just be careful here. This is sloping up to the left, which means it's a negative slope. So I'm going to make that, if you're doing this rise over run method to find the slope, you have to account for whether it's positive or negative. So our slope, m, is minus b over a. The y-intercept, c, is given to you in the question. It's the point 0, comma, b. So in our case, the y-intercept, this bit here, is actually b. So now we can plug those values into our equation. So y is equal to mx plus c. So m, our slope, is minus b over a times x plus the c, and our y-intercept is actually b. So this is the equation of a line, but we need to show it written in this form. Okay, so if I look at the first part of this, I have y, but up here I have y over b. So I'm going to divide across by b. So if I divide y by b, I get y over b. If I divide minus b over a x by b, I'll get minus 1 over a x. And if I divide b by b, I get 1. So it's looking a bit closer to the shape I want. I want x over a plus y over b equals 1. So I'm going to leave the y over b here. Minus 1 over a times x is actually equal to minus x over a. We're multiplying a whole number by a fraction. Multiply the whole number by the numerator. Plus 1 still. And then I'm just going to bring this term here over to the left and change the sign. So instead of minus x over a, it'll become plus x over a. So that will give me x over a plus the y over b equal to the 1 is the only thing left on the right hand side, which is the form that I want. So that's part A finished. Part B says the line L has a slope m and contains the point A, which is 6, 0. Write the equation of the line L in terms of m. So the equation of a line, we're given the slope and a point. So this time for the equation of a line, I'm going to use the formula y minus y1 is equal to m bracket x minus x1, because we have a point and we have the slope. So the point we have is 6, 0, so that's our x1, y1 point. So we're going to sub that in. So you've got y minus 0 is equal to the slope. M is just m again in the question. Bracket x minus 6, the x1 value. So that becomes y is equal to m bracket x minus 6. Okay, they haven't asked us to put it in any particular form, so that's fine there in that form. And that's the end of part B1. And finally, part 2, B2, says the line L, that's the line we've just found the equation of, this line L cuts the line K, which is 4x plus 3y equals 25, at a point P. Find the coordinates of P in terms of m, and give each coordinate as a fraction in its simplest form. Okay, so we'll just rewrite out this formula here. Y is equal to m bracket x minus 6. And then in here, that's the line L. The line K is 4x plus 3y is equal to 25. Okay, so we're trying to find where these two lines intersect. So we're going to have to solve them simultaneously. Now you could do this by elimination or by substitution. Now because we've got m's involved, I'm going to do this by substitution, because this first line here is already it's already has y as the subject. So I'm going to sub this value here. Basically, this y, I'm going to put it in here to this equation. So instead of the y, I'm going to put in m bracket x minus 6. So that's going to help me find one of the values in terms of m. Remember, m is allowed to be in my coordinates. So what does that give me? I have 4x plus 3 times y, which is actually m times x minus 6. And that then is equal to 25. So just to be clear there, I'm just going to highlight there, this bit here got subbed in from the top line. Okay, so now what have we got? We have 4x plus 3 times m by x is mx, m times minus 6 is minus 6m, and that's equal to 25. So that gives me 4x plus, I'm going to multiply the 3 in now, 3mx minus 18m. So that's multiplying the 3 in this way, and that's equal to 25. So I'm going to try and find x. So I'm going to leave the 2x terms on the left. I'm going to bring this minus 18m over here. So it's going to be 25 plus 18m, change the sign. Now I'm going to factorize x out of this. X is equal to 4 plus 3m. That's equal to your 25 plus 18m. And now I'm going to divide both sides by 4 plus 3m. In other words, I'm going to make x the subject. X is equal to 25 plus 18m over 4 plus 3m. So now I have my x coordinate of the intersection point. So this is my x coordinate. And now I'm going to sub this back in to find my y coordinate. So I'm going to sub this back in to one of these equations. So I'll probably sub it back into this first one because I'm trying to find y and that's already the subject. So what have we got? So y is equal to m bracket x minus 6, m bracket x minus 6. So now I'm subbing this x value here. Now I'm going to sub it in here to get my y in terms of m. So y is equal to m times 25 plus 18m all over 4 plus 3m minus 6. And again, just to be clear, I've subbed so I've subbed the x, this in for the x. So that's this here. That's being substituted in there. So that gives me y is equal to, you can multiply m by this, gives me 25m plus 18m squared over the 4 plus 3m. So I've just multiplied the m by this fraction, so the m multiplies by the top. And then, that's that bit done. And then the m multiplied by the negative 6 is minus 6m. So I need to express this as a fraction in its simplest form. So let me see. It's a fraction minus this. So y is equal to, I'll express this over the common denominator. This is 6m over 1. So the common denominator of 4 plus 3m and 1 is just 4 plus 3m. So the top of this will remain the same. That's 25m plus 18m squared. And then 1 goes into 4 plus 3m times. So I multiply the 4 plus 3m by 6m. So minus 6m by the 4 plus 3m. So a bit more tidying up to do. I've got y is equal to 25m plus 18m squared. Minus 6m times 4 is minus 24m. Minus 6m times 3m is minus 18m squared. All over 4 plus 3m. And one last bit of tidying up now. This numerator 18m squared minus 18m squared, they cancel nicely. 25m minus 24m is just m, and the denominator will stay the same. And that is my y coordinate in its simplest form. So if you remember, the question said, give each coordinate as a fraction in its simplest form. So the x coordinate we had was this one here. And that's in its simplest form. There's nothing I can factorize top and bottom here. So 25 plus 18m over 4 plus 3m. And then the y coordinate is m over 4 plus 3m. Again, nothing you can factorize here. So that's the end of question 2.